So we have this circuit, and we want to find the total current delivered by the battery. So let me launch the poll, and I'll give you a little bit of time to think about it and work through it. So you're going to have to probably work through it. You might have to redraw the circuit as you're solving this problem. Unless you're really good, it's hard to do this off the top of your head. So as you think about it, I'm going to draw a picture on the board. Oh yeah, and all the resistors are equivalent. Yeah, good question. The curved section basically represents one wire going over another. It's not an intersection. All right, we have one response so far. Okay, we have two responses. Almost there. So let's take a little thought. This was not that easy. All right, so everyone's responded. I have a nice distribution of answers. So let me, oops, what happened? Okay, there it is. Let me end the poll and share the results. So you all see the results, right? So most people chose the last one. Okay, so let's go over this one. And there's different ways of looking at it, and I prefer, I just have a preference, so. If you want to put numbers in, you can. I can make this, let's say this is 9 volts. This is 0 volts. This one is 9 volts. And so what I'm going to do is mark points in the circuit. This point is at 9 volts. This point is connected to this point. This is a direct short. That's 9 volts. This point is connected to here, 0 volts. This point is connected to here. Now let's think about that. This is at 9 volts. This is at 9 volts. What must this be at? Well, these two are connected together, right? I have 4 resistors. How many resistors have a current running through them? Is there any current going through this resistor? Hold on a second. So, is there any current going through this resistor? No. So you have 9 volts across this one, 9 volts across this one, and 9 volts across the other one. So you basically have 3 resistors that have current running through them, and they all have 9 volts across them. So isn't it true that I can write the circuit in this manner? And since each one has the same power supply voltage, okay, it's 9 volts, whatever you want to call it, delta V, then the current is going to be delta V over R on this one, delta V over R on this one, and delta V over R on that one. And the total current delivered by the battery is going to be this plus this plus this. And so I total has to be equal to 3 delta V over R. Okay, in the problem they use V. Remember this is a node, so the current splits up over here. So 1/3 is here, 2/3 is over here. That problem should look familiar. I did a problem class that looked like that. At least the final circuit. Are we okay with that? Questions on it? Some people are actually just they trace the currents. I have a harder time with that, so I just write the V's everywhere. I identify where all the V's are the same. That's my that's the way I look at it. But some folks do it differently. They just follow the paths. Yeah, if you have a direct short, I mean, all the current, ideally, all the current will go through through the direct short, right? Obviously, a direct short, there's still a tiny resistance. With like 99.99% of the current will go through that short. So you're asking about this one? Andrew? So this wire, this is just a wire. It has no resistance. So there can't be a voltage drop. That means the potential here and the potential here are the same. It's the same thing as if I took these 2 points and connected them together. There's no difference. That's why I can write 9 up there. Yeah, you got to include that. You do have to include that. And there's all kind of interesting problems you can do with these kind of with circuits. Okay, let's do a Kirchhoff's law problem. And again, this is going to take a little bit of time. You have this circuit, and this circuit has 3 power supplies. The currents identified, although they have not applied the current rule in this particular example. But the question is, you want to find oops, I messed up I didn't copy the question correctly. Just give me a second, okay? Let me recopy that question. I screwed up. Just 1 second. I was in a hurry and I messed up. I will fix that. I just got to find the question, and then I'll change it real quick. For some reason, it's not cooperating. All right, just give me a second. Let me do this because I'm having trouble. Let me present the question this way. For some reason, it's not allowing me to copy like I usually do. So the idea is you want to apply Kirchhoff's loop rule starting at point B, and going through, no, that's not the one either, sorry. Hold on a second, that's not the question I wanted. All right, so here's the question. So starting at point B and going counterclockwise, actually, it's not right. You want to go through batteries E2 and E1. Starting at B, go counterclockwise through E3 and E2, sorry. Okay? So basically you want to look at the loop on the right. You want to go counterclockwise. I'm going to go counterclockwise. And which one of those equations would be the correct one if you apply Kirchhoff's loop rule? So let me relaunch poll. So we're going counterclockwise in this loop. The loop on the right. This one should take a little time, but it shouldn't be as hard as the first question we did today. I have 3 out of 5 has responded. Okay, 4 out of 5 responded. Okay, we have everyone who's responded. So let me end the poll and share the results. Okay, so let's see how you did on this one. Let me stop sharing. Okay. I probably don't need to go onto the board to do this, so let me just keep this same view. In fact, let me modify the figure real quick. I can make that circuit bigger since everything else is messed up in this slide. Okay. So I want to go counterclockwise, starting at point B. So I'm going to start here and go counterclockwise. So when I go through the first power supply, E3, is that a gain or a loss? Does the voltage increase or decrease? That's a decrease, right? So I have minus E3. And then as I go through resistor R3, what happens when I go through resistor R3? I'm going against the direction of current. I'm going against the electric field because I'm saying the electric field's downward. That means the electric potential has to increase. So the potential increase across R3 is the current through it times R3. So I have plus I3R3. So based on the first two that I've gone through, you can already see the answer, right? Which answer is it? Well, it's got to be D, because I already said going counterclockwise through the battery, I have a voltage drop, minus E3. I go through R3, but I'm summing against the direction of the current. That means the voltage increases. That's plus I3R3. I get to the second power supply. I get a voltage drop, minus E2. And then I go through R2. I'm going against the direction of current. That's the voltage increase. The plus I2R2 equals 0. Does that make sense? Are we okay with that? Any questions? So the answer is D to that one. And most people got that right. You guys still there? Okay. All right, one more question. This should be, hopefully, I think this one should be quick. Could be wrong, but we'll see. Whoops. I want you to see double. So you have graphs representing, well, you want to know which one of the graphs represents a capacitor charging to a higher voltage. On those graphs, the vertical axis is the charge on the capacitor. The horizontal axis is time. So think about it for a moment and see which one of those equations represents the charge on the capacitor as a function of time as the voltage increases across it. As a hint, I showed you this graph in class. Okay, everybody's responded, and this wasn't too long of a problem. So let's end the poll, and let's share the results. And again, I want you guys to see double. Oops, sorry about that. Let me bring that back. Okay. Let me change views. I'll stop sharing. That's our last question. Well, I mean, I wrote down the equation for a capacitor that's charging. I wrote this. At t equals 0, this function is 0. And then at t equals infinity, this reaches a maximum value of q max. And so this is an exponential function. It's going to look like this. And so selection number 4 was the answer. Selection number 1 would represent the current in the circuit as the capacitor is charging. Graph number 1 could also represent the current in the circuit. I'm sorry, yeah, that's right. It could also represent the current in the circuit when the capacitor is discharging. And number 2 has nothing to do with RC circuits unless you plot the natural log on the vertical axis, which is one of the questions. You had something similar to that in one of the discussion problems. Any questions on this? So I have been tallying up points for the questions you've presented and the responses to the questions. So I've tallied them at least in terms of what you have so far. So one of the things is, as a reminder, if you are presenting a problem for the week, you do not have to respond to other people's questions. You just present your own question. Is that everybody else has to respond to the questions, okay? So it's enough, you have enough work to present the solution. All right. So some people have not been responding to questions. So part of your grade is to respond to the problems in the discussion board. So make sure you do that, because otherwise those are, they're 1 point each, so you're losing points if you don't respond. Okay. So I did respond to one of the questions today. It was the one with the curve fit. The only thing I cheated, I did it in Davis, so I could do it real quick before class. Okay. Do you folks have questions now on the web assign? Either homework 4 or 5. I'm sorry, either homework 5 or 6. Either one. Okay. Yeah, the only unfortunate thing is the exam is next Wednesday. So I might take a little bit of time on Monday to maybe answer 1 or 2 questions that's causing people headaches. Okay. On Monday. So on Monday, I'll real quickly try to see if anybody has questions on the homework. As I go through this last problem, or this is the problem I was talking about in class today, where you'll find when you solve this problem, that exponential equation, you're hardly going to use it. Okay? This problem number 16, for example, you're really looking at, in a lot of cases, at limiting cases. Yeah, RC circuits will be on the exam. Everything in chapters 26, 27, and 28. That's why I want to ask questions. I want to go through the problem on Monday, the one I was talking about, and then ask any questions you may have. Okay? And then don't forget, there's on Canvas the conceptual questions for Unit 2 you might want to go through. And I will say that on this assignment, most of these problems are, I think the first 10 are pretty straightforward. I mean, it's easy to make algebra errors, but the first 10 on here are, I'd say the first 11. This is one that number 11 was one that might cause a little bit of problem. So let me just say something about number 11. You're going to have to analyze this circuit. You're going to have to use Kirchhoff's laws to analyze this circuit. What should you do to simplify that? In other words, to make the math easier, what should you do? When you look at that circuit and you want to use Kirchhoff's laws to solve it because you have two power supplies in your circuit, what should you do to simplify it? I mean, you can apply the Kirchhoff's laws directly. You're going to have extra work. But you can make one simplification to this circuit to make life easy for yourself. What do you think you can do? Well, in that circuit, what is the potential difference across A and E? It's 0. So isn't it true that the 4R resistor and the 3R resistor are in parallel? Couldn't you combine them then? Right? Couldn't the 4R and 3R just be combined into one resistor? I'm not sure I'm not sure I understand what you mean by expand at point C. I'm not going to expand it. I want to combine those two resistors into one. Then I only have 2 loops. And once I find the current through that resistor, I can find the voltage across each 2 resistors and the current through each of those 2 resistors, and I can find how much current is flowing between A and E. So that'll make life a lot easier for you to do it the brute force method. Okay? Or maybe it's for practice, you can try it both ways and see what happens. You should get the same answer. So that one's a little bit of a challenge. This one, it's messy. This one's not that hard. So 13 is pretty straightforward. So 10 is, or 12 is a little bit challenging. 13 should be straightforward. This one's a little bit challenging, but again, you're looking at the circuit at extreme cases. 15 should be straightforward. I mean, these 2 resistors are in parallel. These 2 capacitors are in parallel. It's a pretty straightforward circuit. This one's a little more challenging. Like if you had to solve this for the Q as a function of time, that would be a fun problem. And I might talk about the problem I'll do it in class on Monday. What would you do if you had to solve for Q as a function of time in a system like this? It would take some work. You'd have to set up two equations with two unknowns, and they're both differential equations. You can solve those. Just treat them like systems of equations. 17 is a nice problem. 17 is like a problem I did in class with the ammeter, except here now, this capacitor is charged up. There will be a potential difference across the capacitor when it's charged up. Okay. And for this last thing here, you don't have to enter. If you just put yes in here, it should give you credit. But a lot of these other ones are fairly straightforward. And I think on your conceptual questions, for Unit 2, I have actually this question in there. Okay. Okay. If you don't have any questions, then I'm going to end it here. And I'll use a little bit of time Monday in class to answer some questions. Are we okay? Everybody else okay? Okay. So have a nice weekend. And again, if you have questions on the lab or this homework, please, contact me. Use the Discord.